So very good morning to one and all present here. So I welcome all the students, faculties for this online guest lecture on geosynthetic application in civil engineering. The session will be handled by Dr. J.Jayapal, Asst.Prof, Department of Civil Engineering, NIT Jamshedpur. So before getting to the today's session, I would like to give a brief introduction regarding the speaker. Dr. J.Jayapal is presently working as a assistant professor at the National Institute of Technology in Jamshedpur, Jharkhand. He earned his BE degree in civil engineering from Ph.D. College of Technology, Coimbatore, affiliated to Anna University in the year of 2007. He then worked as an engineering trainee at a deal of consultant in New Delhi for about 1 year and was involved in construction of IT park in Manapakkam, Chennai. He then obtained his ME degree specialist in soil mechanics and foundation engineering from the College of Engineering Guindy, CEG campus, Anna University in the year of 2010. Following this, he had worked as an assistant professor for a few years in a private engineering college in the teaching field. He have handled a number of subjects in the stream of civil engineering. He then earned his Ph.D. degree in civil engineering with a specialization of geotechnical engineering from IIT Madras in the year of 2021. Afterward, he just before joining this current position, Dr. worked in several national international conferences during the he also worked at Gujarat. And also in the year of 2024, he just cracked the same Indian Geotechnical Conference organized by IGS Aurangabad chapter, Maharashtra. He also carried an award letter from Springer worth of 75 euros. So with this short, brief introduction, I would like to hand over the session to Dr. Jayapal to carry out this session. Sir, it's over to you, sir.
Well, thank you very much, Hari, for a nice introduction. First of all, I would like to thank the authorities of SVC for giving me an opportunity to share some amount of knowledge that I have gained so far during my research and during my teaching somewhere here at NIT Jamshedpur as well as at IIT Madras and at IIT Bombay. So let me share the screen. Can you see my screen, Hari?
Yes, sir. Yes, sir. It's reflecting.
And is my voice audible?
Yeah, audible. So you can proceed, sir.
Okay. Then thank you. If at all, if my screen is not appearing or if my presentation is interrupted, just call me then and there. Okay.
Sure.
Okay. So the topic of today's presentation is going to be geosynthetics application in civil engineering. So I have kept this presentation so very simple that I understood that the audience are from second year civil engineering and final year civil engineering students. I didn't want to complicate things much. We'll have a general presentation of what are all geosynthetics, where we use, and right now, what is the scenario that's going on. Of course, this particular topic is being taught to engineering graduates for one full semester, and covering that entire subject in one single hour is pretty difficult. Of course, I'll try to give some extract or I'll try to throw some light on what are all geosynthetics, where and all we can apply. And currently, what's happening with geosynthetics is what is the topic of discussion today. So I want you to notice this screen over here with a green tea bag. Towards the left and right, we have the logos of my own institute and SVCE. So I'm Dr. Jayapal, serving currently as assistant professor at NIT Jamshedpur. So the presentation outline is going to be introduction, followed by some geosynthetics, what is called geosynthetics, what are the different types of geosynthetics, what are all the functions, what are all the applications in engineering, And finally, what are all the opportunities for civil engineers? Maybe if time permits, I'll touch on that. If not, it's very directly understood. After listening to my presentation, you'll get to know the scope of the opportunities that are available for civil engineers. So if you see this particular picture, we have this particular branch called civil engineering, which was once called as military engineering, that deals with structures supported in the ground or built using natural soils or rock materials. See, foundation is very, very important. If all the structures, if they are not found properly, either they have only three choices: either they have to fly, either they have to float, or they should fall over. If they are not properly founded, either they have to fly, float, or fall over. Whatever applications that you see in front of the screen are all the geostructures, starting from cut slopes, embankment dams, building foundations, supported excavations, constructions on soft soils, closer to the port areas, marine soils, offshore foundations, road embankments, and almost all the areas what you see here in the screen, we have the application of whatever we call it as geosynthetics. So this is a very fundamental thing that every civil engineer should understand, in my own opinion. So there are only three types of stresses in civil engineering. One is called compression, the other one is called tension, the third type is called as shear. So what we teach in civil engineering is only three different types of forces. Apart from that, we have other forces also. Let's keep that aside for this presentation. So we'll focus more about how soil is responding for compression, tension, shear. All these things you have been taught in your civil engineering in the subjects of strength of materials, engineering mechanics, and from fluid mechanics to geotechnical engineering. Maybe final year students would appreciate all these things. So before I start, let me start with a disclaimer. Whatever pictures that I show are all, some pictures are borrowed from my own professor, my teacher, Professor Rajgopal, who's a retired professor from IIT Madras. Some pictures are borrowed from consultants, field consultants. Some pictures were borrowed from internet, some my own work, and some others from different sources. So when you're uploading this video, or people who are audience of this video seeing this video should be aware of the acknowledgements given to the people who had originally worked on that particular area. Okay. So we have different types of problematic soils in geotechnical engineering, starting from expansive soils, soft marine clays, loose silty sands. You see that the key characteristics are populated here. You have very high clay contents, water content, they are of low density, they have very high plasticity, low cohesion, high compressibility, low bearing capacity. So these are all the typical issues that we have with different types of problematic soils. Okay. So apart from that, we have collapsible soils, peats and organic soils. I hope in this presentation, I'm going to use both English as well as Tamil for easy understanding for students who are from Tamil medium background or people who don't understand English much. I'm going to in between use the Tamil language for better clarity. Okay, so we have this collapsible soils, peats and organic soils. All these soils usually are being discussed by civil engineers to usually avoid. So when you have PT deposits, organic soils, especially if you see in Tamil Nadu, in Kodaikanal, you have a lot of peat or organic soils. So usually these peat and organic soils are not suitable for construction. Usually civil engineers are suggested to avoid all these soils. Apart from that, you have dispersive soils, saline and sodic soils. You have these volcanic soils. You see they have their own unique characteristics like presence of dispersive clay minerals, high soluble salts. You have high fine content of ashes. You have these sodic soils with very high pH. You have low carbon exchange capacity soils, something similar to your dispersive soils. So you have typical issues for every single kind of soil. So the problem is construction or planning for a construction in all these soils is going to be very, very difficult, or it should be, or I would be calling it as challenging. Okay, so when it is challenging, the engineers are forced to think about alternative methods for solving the problems that are arising due to these kind of problematic soils. So all of these soils, let's say for example PT clays, liquefiable soils, are coming under this particular category. So you can just go through all these key characteristics and the typical issues that are following with these kind of problematic issues once I share this presentation with Dr. Hari. So jumping on to what is called as a geosynthetic. So geosynthetic is fundamentally a natural or an artificial product that is used along with soil in geotechnical constructions or geo-environmental constructions, or simply to some extent I can call civil engineering constructions. So you have both natural products as well as artificial products. So natural products, you have coir, jute, hemp, etc. You have artificial products, namely polymeric products or metallic products. So when it comes to polymers, you see here, there are different types of polymers used in geosynthetics. Probably in chemistry, you might have studied different types of polymers. So polymers are fundamentally some elements that are joined together with single units called as monomers. Okay, so all the geosynthetic products that we are going to discuss about, majorly, if not about the natural geosynthetics or geonaturals, all of the other major geosynthetic members in the geosynthetics family are all made out of polymers. So the word polymer is derived from Greek language. Poly means many, meros means parts. So it has many parts. You link all these parts in the form of monomer to get a polymer. Okay. So you have monomers. So polymerization is the process of agglomerating or combining all the products into a polymer. So finally, what you get is a product. Okay, geosynthetic product. So there are different types of geosynthetics. I want you to pay attention here. You have geotextiles, you have geomembranes, you have geogrids, you have geosynthetic clay liners, you have geofoam blocks, you have geonets. There are n number of products. If you go to the market right now, there are plenty of products that are available in the market. You have geocells, you have geobags, you have geocomposites. So these are all some advanced, 1 minute. These are all advanced addition to geosynthetics family called as geocells. Okay. So polymeric materials, which are fundamentally or specifically manufactured to be used in geotechnical and geoenvironmental applications, are made out of this geosynthetics are made out of all of these polymeric materials, and then we use it accordingly in different sites. So the general definition, what we have said, is different, but the fundamental actual definition provided by American Society of Testing Materials, it's that it's fundamentally a planar product manufactured out of polymeric material used in soils. It could be in rocks, earth, or any other geotechnical engineering material, related material, which forms an integral part of a human-made project or a project structure, or it could be a system. Okay, so this is the actual definition provided by American Society of Testing Materials. In India also, we have a code for geosynthetics, IRC codes, IRC specifications. So you might have heard about reinforced concrete. So the idea of reinforced concrete is like, concrete is good in compression, weak in tension. So you supply some material which is good in tension to compensate for the redundancy or the deficiency. Okay. So it's the same with soils. You see here, you have a reinforced soil here. So if you combine soil plus reinforcement, it becomes a reinforced soil. Okay. So this reinforced soil is fundamentally with geosynthetics. So initially, traditionally, people started using tree branches, grass reeds, straws, root of vegetation, bamboo, tree trunks. In fact, if you go and strike the internet, you can see that even the Great Wall of China, when some part of that particular wall was broken, they could see lot of natural materials, usage of natural materials to build that great wall. Okay, long wall that's been built in China by this kings of Han dynasty. Okay, so you have modern, we have steel type of reinforcements, we have polymeric reinforcements, you have natural materials, and it is already understood that soil is good in compression and the reinforcement is strong in tension. So the combined, composite material is suitable for taking both compression force or a tension force or both. Okay, so this combined product has much better engineering properties than individual constituents. So the reinforced soil concept is similar to that of your reinforced concrete, as I said earlier. So why does reinforced soil work? Let's say, for example, hypothetically, you are trying to arrange these marbles in a box with some confinement. Okay, if not, they'll fall away. So let's say, for example, we are trying to arrange all these balls in some arrangement with some confinement over here. And if you remove this confinement, all these balls will try to move away. Why? Because there is no tension resistance or tensile resistance is not available. Whereas if I put these reinforcements or place some reinforcements, so these tensile forces are mobilized all over, and then they are able to some extent stand, virtually without sliding away. So it's the same concept here. You are providing some additional support using a member which can take tension. Okay, it's the same concept here called as your reinforced soil. This is yet another beautiful example that is seen in the internet. Okay, this experiment also you can try it out by making out a small box like this, which could be opened using this hinge arrangement, and you try to fill up this particular box with gravel soil or maybe any coarse grained soil. So you just make that plank on that particular soil. You slowly remove this box layer by layer or from this side by side. And if you ask any person to stand, you can see that, of course, he can stand, but you can see the amount of deformations that you experience or the soil is experiencing here, the gravel is experiencing here. So this is on one side without any reinforcement. The second case, what you do is like you again fill the same box with gravel, but on a layer by layer basis with some reinforcement. Okay, so if you place all these reinforcements, let's say for example geogrid, geotextile, or whatever composite or whatever reinforcement on a layer by layer basis, again what you do is like you put this plank on top, and then if you stand on it and slowly if you remove the confinement over that, you can see that the deformations are less, and more importantly you can see that the height is increased. You can build more heights. So in this way, you can see that the reinforcement is working, or the concept of reinforcement is applicable. So before I switch on to this functions and applications, so we will see through an image the mechanism of reinforcement in soils. You see here, I'm just zooming inside for your convenience. So the basic concept is you are reinforcing the soil with different types of materials, namely geotextiles, geogrids, geocells, geofibers. So they interact with soil to develop, resistance against deformation. So it is going to mobilize tensile forces. It's going to provide confinement. It is providing the strength, stiffness, stability of soil structures. You see here the tensile resistance is mobilized, or the the tension mechanism in the reinforcement is mobilized with different types of key mechanisms. You can see that you have the tensile membrane effect when you place it inside the soil, or it can be experienced as a interaction through friction if you again place it in the soils, or you can say that it provides a lateral restraint again if you place the reinforcements inside the soils. And more importantly, when it comes to the case of geogrid, all of these particles get aggregated or get interlocked inside the spaces or apertures provided inside this geogrids. Okay, it's an interlocking mechanism. And apart from that, you get the effect of spreading all these loads or spreading the tensile forces all along this membrane such that load is effectively transferred. Okay, so the key mechanism of reinforcement is through tension membrane effect, friction effect, lateral restraint effect, mechanical engagement effect, interlocking effect, and then the spreading effect. Okay, so if you look at this particular stress strain curve of your reinforced soil and then your unreinforced soil, you can see that unreinforced soils suffer only low strains and low stresses. And if you plot again for the reinforced soil, you can see that the stresses that are experienced by this reinforced soils are pretty much higher, and for longer strains and for larger strains. Okay, so this is very, very important for you to notice. And you see here, you have plenty of applications I'm going to make you, comfortable with in the due course. So you can see that the reinforced embankment on soft soil can be constructed using these reinforcements, wherein the stability is increased and it reduces the settlement by improving the load distribution. You can take a typical example of a retaining wall. Possibly retaining walls you might have studied during your earth pressures related to K0, Ka, Kp. Okay, whatever type of retaining wall, with reinforcement you can just construct and increase the height of the wall. And you can see that the reinforced slopes can also be constructed with appropriate reinforcements such that you don't have a slope failure or a slope instability. And apart from that, we have wide variety of application of reinforcements in pavements. Okay, so finally you see here the reinforcement works by mobilizing the tensile resistance, frictional interaction, confinement, transforming weak soils into strong soils, stabilizing, and finally giving us a reliable foundation. Okay, so this is the overall idea of the reinforcement mechanism or the way or method in which this geosynthetics work. Okay, let's get back to the presentation here. So you have different types of functions. I want you to notice the functions very, very carefully. So you have separation function, you have the reinforcement function, you have the stiffening function, you have this filtration function, you have barrier function, you have drainage function, you have protection functions. So all of these functions are called as the important functions that are provided by this geosynthetics. And not only individually, let's say for example, they can combinedly, the individual reinforcements can combinedly act as separation members, it can act as a reinforcement, it can act as a stiffener, can act as a filter in combination. It can also sustain as a barrier, and some composites can be used for drainage, and to some extent, or in certain cases, you can use the geosynthetics as a protective layer. So I'm not going to read the applications for now. Probably you'll understand when we travel with the different set of applications. Okay. As I said, you have geotextiles, you have geogrids, you have geonet, you have geomembranes, you have geosynthetic clay liners. This is a special product actually, geosynthetic clay liner, which is a combination of clay powder and a synthetic material. And then you have geopipes, you have geofoam, called as your expanded polystyrene, EPS, expanded polystyrene. You have geocomposite. So if I combine the textile and grid, it becomes a composite. If I combine a grid and a net, it becomes a composite. Okay. So I have listed out what are all the different types of functions all of these polymeric materials deliver. You have separation, reinforcement, filtration, drainage, and containment. When it comes to geotextile, it can be used as a separation member, reinforcement member, filtration member, and a drainage member. You get to see a geogrid. It can be primarily used as a reinforcement. A geonet can be used in drainage. Geomembranes used only in containment for retaining toxic fluids in chemical industries, in landfills. So geosynthetic clay liners again used in landfills. Geopipes for transporting liquids, toxic liquids used in drainage. Geoforms, this is a very advanced kind of product. Of course, in India, we don't have these applications. We know colloquially, or we colloquially call this geoform as thermocol. So whatever we call it as thermocol is a type of geoform and not the exact geoform. The actual geoform is technically called as EPS, expanded polystyrene, EPS. Then you have geocomposites, which is a combination of textile, grid, net, membrane, anything. Okay. So before I step into the roadway applications, I'll just show you the type of geosynthetics once more. So this is basically a textile. This is a membrane. This is a grid. You have geosynthetic clay liners. As I already said, it's a sandwich of clay powder, possibly a bentonite powder, stitched with top and bottom carrier and cover geotextiles. And then you have geofoams, okay, expanded polystyrene, and then you have geonets. These are all the major members in the geosynthetics family. Apart from that, there are other special products. Maybe if time permits, I'll touch. So all these things are planar products. As I say, these are all planar products, but this particular product is a 3D product, okay, three-dimensional product. You have geo bags and then you have geo composites. Okay, let's dive into the applications very quickly for the want of time. So இப்போ roadways application நீங்க எடுத்துக்கிட்டீங்கன்னா you have subgrade, subbase, base, and then the surface. So the surface தான் வந்து you can see that it is an asphaltic overlay or the original pavement. You can see the base here. Probably in transportation engineering, you might have designed the pavements using CBR, using resilient modulus, other things, I don't know. So you see here, you have subgrade, which is the fundamental soil. You have subbase, you have base, and then the surface. So I'm just going to show you where and all these reinforcements can be used. So this work is being taken from the works of Professor Zornberg, who is working extensively from University of Texas at Austin. He has published a paper, a lot of papers. In fact, one of his wonderful paper is published in Geotextiles and Geomembranes in 2017, especially on the applications of pavement design. So you can see that You can have the reinforcements. You can have the reinforcements here in the base. You can have geosynthetics as a separation layer to separate your asphaltic overlay and original pavement. You can have it as a filtration member below the base and below the subbase, and you can have a type of geosynthetics somewhere here to drain away the excess water that has been coming out because of increasing in water table. And you can see that you can use the reinforcements as a stiffening member somewhere in all of these places. You can see the arrow marks driving, okay, penetrating here. So wherein all of these places you can place the reinforcements or geosynthetics such that you can strengthen the pavement. ஸோ நம்மளுடைய ரோட்ஸை வந்து ஸ்ட்ரென்தன் பண்ணிக்கலாம், அடிஷ்னல் ஸ்ட்ரென்தன் பண்ணிக்கலாம். Why? Because all of the failures, majority of the failures in highways or pavements are happening because of tension, shear. Okay. Typical example எடுத்துக்கலாம். You have two different soils, and let's say for example a truck is running and you have the surface over here. If you don't have, let's say for example this particular soil is a soft soil, if you don't provide any reinforcement or a separation member, what happens is like all these aggregates get punched into these soils, and because of that the traveling comfort will be lost, the surface will be damaged over a period of time, and then the rider will not be comfortable. Okay, rather what you can do is like just place a geosynthetic as a separator so that both the soils are separated. Okay, both the soils are separated or contained, and you can see that the deformations are also less in both the cases. Okay, if you compare, இங்கே பார்த்தீங்கன்னா உங்களுக்கே தெரியும், so the amount of deformation that's happening over here and the amount of deformation that's happening over here is very clearly shown by just providing one member called as a geosynthetic as a reinforcement or a separator. The second thing what you can see here is like you get to see the additional pumping in of water during the rainy season or during increasing in water table, sometimes during the monsoons. ஸோ அப்போ என்ன ஆகும்னா இந்த சாயில் போய் இதோட மிக்ஸ் ஆயிடும், அல்லது ரெண்டு சாயிலும் மிக்ஸ் ஆகிடும். ஒன்ஸ் அந்த சாயில்ஸ் மிக்ஸ் ஆகிடுச்சுன்னா இந்த டிரைவருக்கு அல்லது பேசஞ்சர்ஸுக்கு கம்ஃபர்ட் கிடைக்காது, ரோடும் டேமேஜ் ஆயிரும் ஓவர் அ பீரியட் ஆஃப் டைம். ஸோ வாட் ஹேப்பன்ஸ் இஸ் லைக் யூ ப்ரொவைட் அன் அடிஷ்னல் லேயர் of reinforcement to just act as a drainage member, okay, as moisture infiltration, and this is your base, this is your subgrade, and this is your water capillary rise during your monsoon season. So what happens is like all these products, they transfer water, they push inside water to sideway drains, and then you can just pump it out over a period of time. There are plenty of other products available. In fact, there should be a separate seminar only for the products. Plenty of products are available, but we'll just see only the engineering applications. So this is a very beautiful slide that shows you what happens when you place a geosynthetic and what happens when you don't place a geosynthetic. So again, the same typical example, you see that you have a tire here, you have a tire here wherein the vehicle is passing. All the loads are distributed on or I would say it is not distribution, it is concentrated in a specific place when these two soils are not separated or when these two soils are not sufficient enough to take care of the loads that are transferred from the wheels. Okay, so you get to see a concentrated stress somewhere here, and when you place a reinforcement, you can see that additional lateral restraints are introduced and the tensile strains are mobilized all over. So இங்கே உள்ள லோட் டிஸ்ட்ரிபியூஷனும் இங்கே உள்ள லோட் டிஸ்ட்ரிபியூஷன் நீங்கள் பார்த்தீங்கன்னா தெரியும். ஸோ இங்கே உள்ளதை நான் stress distribution சொல்ல மாட்டேன். So it is going to be stress concentration, whereas here it is going to be stress distribution. You can very well see the catenary shape wherein the stress is uniformly or distributed in a pattern such that the load is effectively taken care. Okay, this is again one more effect. inga sonna mari because of stress concentration you get to see a punching failure over here, and here in this case you generally get a general shear type of failure. Probably in geotechnical engineering you might have studied what is called as your general shear failure or a punching shear failure. Okay, so you can differentiate between general shear and punching shear. Okay, so this is a very, very important application in flexible pavements. So because of change in temperature, because of change in moisture variation, what happens is like stress variation நால என்ன நடக்கும்னு பார்த்தீங்கன்னா மேலே இருக்க pavements or asphaltic overlays வந்து crack ஆக ஆரம்பிக்கும் due to difference in temperature or due to இந்த monsoon seasons எல்லாம் பார்த்தீங்கன்னா இந்த இடத்துல cracks initiate ஆக ஆரம்பிக்கும். இங்கே இனிஷியேட் ஆகிற கிராக்ஸ் ஸ்லோவாக ரெஃப்ளெக்ட் ஆகி மேலே வந்துடும். ஸோ திஸ் இஸ் கால்ட் அஸ் யுவர் reflective cracks. So cracks initiated and gets reflecting over the top. So இதை நம்ம எப்படி எஃபெக்டிவாக அட்ரஸ் பண்ணுறோம் அப்படின்னு பார்த்தீங்கன்னா, so what you do is like you place the geosynthetic. So this geosynthetics, when you're placing, what happens is like it is effectively addressing the or stopping the crack. So on one aspect. Second aspect is like the strains, tensile strains are mobilized all along. இந்த மெம்பர் வழியாக இதை கடத்திடலாம். Tension stresses-ஐயும் tensile strains-ஐயும் mobilize பண்ணிடலாம். So this is one important application of arresting reflective cracks in pavements, especially flexible pavements. Okay. So again, it's the same application here. These are all geogrids, just a simple repetition. You can use it in multiple places for easy understanding. Again, retaining walls, நீங்கள் நேரடியாக நிறைய இடத்துல பார்த்துருப்பீங்க, ஹைவேஸில் பார்த்துருப்பீங்க. You can see this type of retaining walls wherein the soil is getting reinforced. So this is called as your reinforced fill. This is called as your retained fill. So when you start building an embankment on soft soil, especially in port areas, இப்போ சென்னை மாதிரி இடங்கள்லாம் பார்த்தீங்கன்னா துறைமுகம் இருக்குது, போர்ட் இருக்குது, அங்கெல்லாம் சாயில்ஸ் வந்து ரொம்ப சாஃப்டாக இருக்கும். இட்ஸ் மீன் சாஃப்ட் கிளேஸ் ஆர் எக்ஸிஸ்டிங். அங்கெல்லாம் வந்து எம்பாங்க்மெண்ட் கட்டுறதே கொஞ்சம் டிஃபிகல்ட்டாக இருக்கும். ஸோ இன் தட் பிளேசஸ் வாட் யூ டூ இஸ் லைக் யூ கோ ஃபார் ரீஇன்ஃபோர்சிங் தோஸ் சாயில்ஸ் டு சம் எக்ஸ்டென்ட் அண்ட் தென் ஸ்டார்ட் பில்டிங் த எம்பாங்க்மெண்ட்ஸ். ஸோ இப்போ போர்ட் ஏரியாஸில் இப்போ ஆயில் டேங்கர்ஸ் எல்லாம் மூவ் ஆகணும் அல்லது மென் அண்ட் மெட்டீரியல் டிரான்ஸ்போர்ட் பண்ணணும். இப்போ ஹுண்டாயிலேருந்து கார்ஸை எக்ஸ்போர்ட் பண்ணி இங்கேருந்து போர்ட் வழியாக கப்பலில் ஏற்றி அனுப்புகிறாங்கன்னா, ஸோ இட் ஹாஸ் டு சஸ்டைன் ஆல் த லோட்ஸ், ஆல் த ட்ராலிஸ், ஆல் த ட்ரக்ஸ் that move around the coastal regions. It's very challenging. So for constructing all these embankments on soft soils, you need reinforcements. So the benefits are like you have high tensile strength, so they interlock with soils, they are cost effective, easy to install. So highly skilled laborers தேவையில்லை நமக்கு இதை இன்ஸ்டால் பண்ணுறதுக்கு. Unskilled labor வச்சே நம்ம இன்ஸ்டால் பண்ணலாம். They are cost effective also. Apart from that, they have applications in the railways. It's like India is right now planning for high-speed rail corridors. Of course, the first high-speed rail corridor is going to come from Ahmedabad to Mumbai. So இப்போ ட்ரெயின்ஸ்லாம் நிறைய ஸ்பீடில் போகணும் அல்லது ஜாஸ்தியான ஸ்பீடில் போகணும் அப்படின்னா, ஸோ ட்ராக் ஸ்டேபிளாக இருக்கணும். ஸோ அந்த ட்ராக்கோட ஸ்டெபிலிட்டியை என்ஹான்ஸ் பண்ணுறதுக்கு வாட் யூ ஹவ் டு டூ இஸ் லைக் யூ ஹவ் டு பிளேஸ் அப்ராப்ரியேட் reinforcements. Okay, so it's for railway track reinforcements. You can use this, geosynthetics for improving the track stability, for reducing the ballast movement and maintenance. Ballast is nothing but the aggregates. So you have ballast, subgrade. So railway reinforcement, track reinforcement, and you bifurcate panningena, you can see that you have different levels of ballast, subballast, okay, and then the rails, actual rails, and then the subgrade. So pavement crack control, it's like for reflective cracking, we have already seen we can use these grids or geosynthetics, especially overhead supports, mast foundations. It provides lateral stability also because of wind load. So again, you have this high tensile strength, interlocking with soil, improves load distribution, reduces deformation, cost effective, and then we are very easy and quick to install. So this particular application, நீங்கள் எல்லாரும் பார்த்துருக்கலாம், it's called as your mechanically stabilized earth walls, MSE walls னு பேரு. Okay, so what you do is like you reinforce the soils and you have these fascia panels to hold all these reinforcements that are connected, and you have the pavements, okay, running on top. Okay, so in India you have this type of walls, whereas in foreign countries you have back-to-back walls. So இந்த பக்கமும் wall இருக்கும், இந்த பக்கமும் wall இருக்கும். Back-to-back walls னு பேரு, B2B. Okay, you can see that this is the base of the wall footing. You can see the facing panels. You can see the soil reinforcement. This is selected backfill, reinforced fill. This is your retained fill. So you have separate drainage provided when and where applicable. You can see the vehicles traveling. So this is a very, very important application. So let's say, for example, there is a slope over here. Forget about this car and this space. Let us initially assume that this is the slope and with only one lane. Okay, and if you want to suddenly increase the height of the slope, what will you do? You have to additionally add soil here, but just after you additionally add soil, your slope cannot be retained. Why? Because it will start to fail. Okay, because of instability. Why? Because this angle cannot be increased beyond this particular slope. Okay, so in that case, what you do is like if you reinforce, you can increase the steepness of the slope. இதனுடைய ஹைட்டை நல்லா எஃபெக்டிவாக இன்க்ரீஸ் பண்ணலாம். அப்படி இன்க்ரீஸ் பண்ணுறது மூலயமா நமக்கு என்ன கிடைக்குது அப்படின்னா அடிஷ்னல் ஸ்பேஸும் கிடைக்குது. யூ கேன் எக்ஸ்பேண்ட் திஸ் லேன் ஆர் ரோட் ஆல்சோ. ஸோ திஸ் ஷாலோ unreinforced slope, if you reinforce it, you get an extra space and then you get additional steepness also, okay, when you reinforce. The exact same application was brought out in this particular real-time scenario there at Vijayawada. So in Vijayawada there is one temple called as Swaminarayan temple. So this is the pathway to that Swaminarayan temple, and they were facing a unique type of problem. So this is a narrow stretch of a single lane road. ஸோ இப்போ அங்கே உள்ள திருவிழா அல்லது அங்கே உள்ள டெம்பிளுக்கு வந்து சாமி கும்பிட போகும்போது பார்த்தீங்கன்னா ஜன நெருக்கடி அதிகம், டிராஃபிக்கும் மொபிலைஸ் ஆகாது. இங்கேருந்து அவ்வளோ தூரத்துக்கு ஆப்போசிட்டில் இருக்கவங்களாலையும் வர முடியாது. ஸோ வாட் ப்ரொபோசல் வாஸ் மேட் இஸ் டு effectively address this issue by building a wall. You can see the wall over here. It's the largest wall that was built at that particular time, which was around 22 meters high, geosynthetic soil retaining wall to widen the road at Vijayawada. So இந்த வாலை கட்டி எக்ஸ்ட்ராவாக டிராஃபிக் மொபிலைஸ் பண்ணி ரோட் ஸ்பேஸை கெயின் பண்ணாங்க. அண்ட் ஐஐடி மெட்ராஸ் வாஸ் த கன்சல்டன்ட் ஃபார் திஸ் பர்டிகுலர் ப்ராஜெக்ட், and my guide Professor Rajgopal was the consultant. So these slides are borrowed from him. It's a very effective application of geosynthetics, real-time example that even now also if you go by train you can see this particular wall. Okay. Apart from that, what we call is textiles. They are also very important members in geosynthetics family. இப்போ நம்ம போட்டுட்டு இருக்க ஷர்ட், பேண்ட் எல்லாமே டெக்ஸ்டைல் தான். ஸோ தீஸ் டெக்ஸ்டைல்ஸ் ஆர் ஃபண்டமெண்டலி பெர்மியபிள் ஃபேப்ரிக்ஸ் யூஸ் டு செப்பரேட், ஃபில்டர், ரீஇன்ஃபோர்ஸ், ப்ரொடெக்ட் ஆர் ட்ரெயின் ஜியோடெக்னிக்கல் இன்ஜினியரிங் அப்ளிகேஷன்ஸ். ஸோ இதுதான் ஆக்சுவலி கால்ட் அஸ் யுவர் ஜியோடெக்ஸ்டைல்ஸ். ஸோ இட் கேன் பி ஆக்டிங் அஸ் அ செப்பரேஷன் மெம்பர். யூ கேன் செப்பரேட் two different soils by providing a geotextile. Let's say for example base course and subgrade. In between you can have a geotextile. So it prevents mixing of subgrade with base materials and maintains layer integrity. And filtration, I want you to notice very carefully. ரெண்டு டைரக்ஷன்ல ஃபில்ட்ரேஷன் நடக்கும். ஒன்று இன்பிளேன் ஃபில்ட்ரேஷன். திஸ் இஸ் கால்ட் அஸ் யுவர் இன்பிளேன் ஃபில்ட்ரேஷன். ஸோ தண்ணியோ நீரோ இதோட பேரலாக ட்ராவல் ஆகும். எது ஒரு பிளேன் ஆஃப் பெர்மிபிலிட்டி. இன்னொன்று வெர்டிக்கல் பெர்மிபிலிட்டி. ஒன் இஸ் ஹரிசான்டல், த அதர் ஒன் இஸ் வெர்டிக்கல். அல்லது எப்படியும் சொல்லலாம் in plane permeability and cross plane or out of plane permeability. That's why you can see that you can have the arrows representing correctly, that you can have the water traveling along this path as well as vertically. ரெண்டு பக்கமும் permeability effective செஞ்சு கொடுக்கும் this geotextiles. Okay, you see here you have drainage members, you have protection members, both acting as geotextiles in all of these applications. So the key benefits with this geotextile is like they can be used as a separator, filter, drainage member, protection member. It can be used as a reinforcement also. They are cost effective, durable, and then they are long lasting. Okay. Apart from that, you have geonets. So grid-க்கும் net-க்கும் நிறைய differences இருக்கு. So grid is primarily used as reinforcements. They are all very strong members, whereas geonets are usually useful for drainage applications. They are a little weaker members. Okay. So you see there you have subsurface drainage or vertical drainage, wherein you can use this geonets, and which is useful fundamentally to collect and convey the water to the pipe and then finally reduce the excess pore water pressure generated during the loading applications or the process. So there is a important application of landfills. Okay, we'll see what is a landfill little later. So you can place this geonets somewhere here as a protector also, and to some extent it collects leachates, which is basically the dirty liquid or the last final waste that is generated out of these landfills. So it conveys it into the collection chamber or a collection system. So it is facilitating this process, okay, for drainage. So the key benefits are, so you can place all of these geonets in multiple applications. Let's say for example tunnel and basement drainage. ஸோ நீங்கள் காட் ரீஜன்ஸில், மலைகளில் டனல்ஸை நீங்கள் க்ரியேட் பண்ணும்போது நிறைய வாட்டர் சீப்பேஜ் இருக்கும். ஸோ அந்தந்த இடத்துலலாம் வாட்டரை கலெக்ட் பண்ணுறதுக்கு அல்லது கலெக்ட் பண்ணி டைவர்ட் பண்ணுறதுக்கு யூ கேன் யூஸ் திஸ் geonets effectively. Okay, so the key benefits are like high flow capacity, chemical resistance, reduces your hydrostatic pressure, it's finally easy to install. So durability, durable and long lasting. These are all factory made products, right? ஸோ இதெல்லாம் நம்ம ஃபேக்ட்ரியில் தயாரிக்கிறது. ஸோ the ப்ராப்பர்ட்டிஸை நம்மளே கண்ட்ரோல் பண்ணலாம். ஸோ we can control the properties. Whatever properties that I want, the engineer will design for me in the industry or in the factory. Okay. As I said, when I combine two different materials, it becomes a composite. So these geocomposites are a combination of two or more geosynthetic products or geosynthetic materials to form or to perform these multiple functions. So one is called as your drainage composite when you have this net and textile. The other one, clay liner drainage system or geosynthetic clay liners that we will see. Apart from that, you have different applications in landfill gas ventilation, pavement drainage layers. So I'm not reading the key benefits. Maybe you can go through it a little later. So the third important product or the other important product is called as a geofoam. So this is very less or very least explored geosynthetic product, in fact, I would say. So இது வந்து ரொம்ப lightweight material. So rigid blocks are used to fill the material to reduce the weight of the structures. ஸோ நம்மளோட ஸ்ட்ரக்சரோட வெயிட்டை குறைக்கணுன்ற மைண்ட் செட்டுக்கு வந்துட்டோம் அப்படின்னா we can use this lightweight materials. Okay. So these lightweight materials, they are not only light in weight, but they are tough also equally. ஸோ ஈஸியாக ஒரு ஆளால் ஈஸியாக அந்த பெரிய பிளாக்கை தூக்கிட்டு போக முடியும். Okay. So the reduction of embankment load on soft soil, let's say for example, in the case of soft soils, மேலே சாயிலிருந்து கிடைக்கக்கூடிய லோடு அதிகங்கிறதுனால லைட் வெயிட் மெட்டீரியல்ஸ் யூஸ் பண்ணுவாங்க செட்டில்மெண்ட்ஸை ரெடியூஸ் பண்ணுறதுக்கு. ஸோ அட் தட் பர்டிகுலர் டைம் வாட் வி கேன் யூஸ் லைக் யூ கேன் ஹேவ் ஆல் ஆஃப் தீஸ் ஜியோஃபோம். ஸோ த டெக்னிக்கல் நேம் ஃபார் திஸ் ஜியோஃபோம் இஸ் யோர் எக்ஸ்பேண்டட் பாலிஸ்டைரின், EPS. ஓகே. ஸோ எக்ஸ்பேண்டட் பாலிஸ்டைரின்லேயே டிஃப்ரெண்ட் டைப்ஸ் இருக்குது. So we are not getting into that, but you can say that whatever colloquially you call it as thermocol, that is very light in weight, but அதை விட ரொம்ப டஃப்பான மெட்டீரியல் தான் இந்த ஜியோஃபோம். இட்ஸ் வெரி டஃப். So in your general thermocol, you can easily peel out the particles or the bubbles. Okay, when you crush it, you can easily peel out. But whereas in the case of geofoam, it's little tough to take out all the balls. Okay, thermocol balls. Okay. If you want to quantify the unit weight of this particular material, it is again 1/10 or 1/20th of the actual material. Okay, 1/10 or 1/20th of the actual material. So what happens is like when you use a lightweight material as a superstructure, in the superstructure உங்களுக்கு அது மூலமா கிடைக்கக்கூடிய ஸ்ட்ரெஸஸும் கம்மி, செட்டில்மெண்ட்டும் கம்மி. ஸோ தட்ஸ் த ஐடியா. ஓகே. ஸோ த அப்ளிகேஷன்ஸ் ஆர் ரன்னிங் பிட்வீன் திஸ் bridge approach embankments, void fillings as lightweight fill. Okay. Wherever you can use all of these lightweight materials to reduce the stresses and settlements. Okay. சடனாக இப்போ ஒரு ரோடை வைடன் பண்ணணும், டக்குன்னு சாயிலை மொபிலைஸ் பண்ணி நம்மளால் அவ்வளோ தூரத்தில் வந்து கொட்டி காம்பேக்ட் பண்ணுறது கஷ்டமாக இருக்கும். ஸோ டைரக்ட்லி வாட் யூ கேன் டூ இஸ் லைக் பீப்புள் கேரி ஆல் ஆஃப் தீஸ் ஜியோஃபோம் பிளாக்ஸ், பிளேஸ் இட் இன் த பேமெண்ட், ஜஸ்ட் டம்ப் த சாயில் ஓவர் தட். ஸோ தட் கன்ஸ்ட்ரக்ஷன் பிகம்ஸ் ஃபாஸ்டர், டைம் இஸ் சேவ்ட். ஸோ நேரத்தை என்னால் சேவ் பண்ண முடிஞ்சதுன்னா மணியை என்னால் சேவ் பண்ண முடியும். ஸோ சேவிங் டைம் இஸ் சேவிங் மணி. And when I save money, I am on the greener side of winning the contracts. Okay. So you see that I can use this as a widening element in soft soils or in the pavements. Apart from that, I can have that in bridge abutments. Adukku kile use pandranga. But in India, the applications are very, very less. In fact, there are no such applications. But in foreign countries, you can have these kind of applications. There are separate codal provisions available in ASTM, especially for this geofoam or expanded polystyrene. In India, இந்த மாதிரி கோட்ஸ் எல்லாம் இல்லை. In future, it will be developed. Okay. Let's say, for example, pipelines-லையுமே பார்த்தீங்கன்னா அதனுடைய அலைன்மெண்ட் டிஸ்டர்ப் ஆகக்கூடாது, இந்த பைப்ஸும் ஸ்ட்ரெஸ் ஆகக்கூடாது பிகாஸ் ஆஃப் த சாயில்ஸ். ஓகே. ஸோ அதனால் என்ன பண்ணுவாங்கன்னா லைட் வெயிட் மெட்டீரியல்ஸ் ஆர் குஷனிங் மெட்டீரியல்ஸ் will be provided. It can act like a cushion as well as a lightweight material for for large diameter pipes and for long pipelines. Okay, carrying different types of liquids or whatever material inside. Okay. So it is going to be light in weight, it's going to reduce settlement, it's easy to handle and install, it's cost effective, it is durable, it's chemically inert also. Okay. And இதோட durability பார்த்தீங்கன்னா holistic-ஆ homogeneous-ஆ ஒரே மாதிரி சேமாக தான் இருக்கும். Why? Because it's again a factory made product. So you don't have variability of of the material along this particular area when you have this blocks. Different types, நீங்கள் இன்டர்நெட்டில் போய் தட்டி பார்த்தீங்கன்னா தெரியும், you have this blocks in different sizes. Okay. Accordingly, you can tailor make and you can create. So let's see this problem very quickly, or let's try to quantify what we have said. Okay, let's say that you have a 7-meter high embankment, which is 60-meter wide. It has to be constructed on a soft clay with water table on the ground surface. So the soft clay oda thickness பார்த்தீங்கன்னா 5 meter இருக்கு. And the increase in stress in the clay layer can be taken as the pressure under the embankment, because the clay layer is thin when compared to that of the width of the embankment. That's fine. So the clay layer has the following consolidation characteristics. Your initial void ratio is 1.1, gamma is 19, your compression index is 0.5. There are two options considered. One is soil fill. The embankment of soil which you fill பண்றோம். The other one is like you can use geofoam, lightweight material. So the soil fill has unit weight of 20 kg per meter cube, and the geofoam fill is 2 kg per meter cube. Okay, so what will be the settlement of the embankment in each case? Okay, so that's our primary target. You see that you use your consolidation theory equations, HCC by 1 plus E naught log of P naught plus delta P by P naught, or sigma naught sigma dash V by delta sigma V by sigma V dash. What you do is like you try to calculate the stresses for both the cases. So you see that both the embankments are of 7-meter height. The thickness of soil is 5 meters for both the cases. Both are soft soils. The only difference is the left-hand side case one is you have soil embankment, and towards the right you have an embankment constructed using an expanded polystyrene or a geofoam, lightweight material. So if you try to calculate the stresses, so your delta sigma V, if you compute, it becomes 20 times the height of the embankment, which is the unit weight. 7 is the height of the embankment. It becomes 140 kPa. And if you want to calculate the initial effective stresses, if you compute it by this equation, 2.5 into 19 minus again the excess porotor pressure that is generated, you get to see this 23 kPa as your effective stress, initial effective stress. And finally, if you plug inside all of these things into the settlement equation, which is nothing but your HCC by 1 plus E naught log of P naught plus delta P by P naught, the settlement பார்த்தீங்கன்னா கிட்டத்தட்ட 1 meter அல்லது 1000 millimeter. Okay, for a soil embankment. Soil வச்சு நம்ம embankment build பண்ணும்போது நமக்கு கிடைக்கிற settlement around 1 meter. Okay. Second case, if you use a geofoam, you have a lightweight fill, you get to do the same calculation again. Finally, what you're getting is like 0.25 meters, which means 250 millimeters. 250 mm தான் settle ஆகும் when you have a lightweight embankment or a lightweight material. So 1/4 settlement என்னால reduce பண்ண முடியுது, and most importantly the time taken to construct that is also less. நான் எடுத்துக்கிற டைமும் less. Okay, so this becomes an advantage for a engineer. Next product is your geocell. நான் முன்னாடியே சொன்ன மாதிரி மற்ற எல்லா ப்ராடக்ட்ஸுமே 2D planar products, but this is not a planar product, this is a 3D product. Okay, so this was initially used in USA. This was actually a military secret, and people used this geocell in US. Then afterwards what happened is like it came for the usage of common public. Towards the left நீங்க பார்க்குறது என்னன்னா, இது அப்படியே நீங்க ஃபோல்ட் பண்ணிக்கலாம், ஃபோல்ட் பண்ணி ஈஸியாக உங்களோட ஷோல்டர்ஸில் கேரி பண்ணிக்கலாம். இட்ஸ் லைட் வெயிட் மெட்டீரியல், again you can easily carry. And if you open it out, it becomes, or it opens like a web or a honeycomb. Okay, so you can see the expanded and the folded type, and you can see small openings over here. So these openings are provided for effective drainage. Okay, so geocells are fundamentally 3D products, permeable honeycomb cellular structures made out of ultrasonically welded strips. So you have this ultrasonically welded strips over here, manufactured with high density polyethylene stabilized with carbon black. Okay, so you have this black color because of this chemical called as carbon black. So in what way this product is effective? It is ensuring the effective transfer of vertical stresses, lateral stresses. You can see the diagram. You can see the hoop tensile stresses. So strength of materials லாம் நீங்க படிச்சிருப்பீங்க, hoop tensile stresses, PD by 2T, PD by 4T. Okay, so this hoop effect is also taken care of with this geocells. So the applications in various sectors, you have roadways, railways, real estate, power plants, irrigation structures, defense sectors, etc. So you see here, this particular slide is been borrowed from Strata Web by Mr. Sharok Bagli. So you see that there was only one road that was connecting Assam and the Northeast India. So the state of roads, you see here, many trucks, many buses or lorries used to get strangled because of this poor soil conditions. So the government was not able to decide on something. So finally, what was the problem is like all of these trucks, lorries get stranded over here, and especially the trucks or lorries that carry oil, maybe petroleum, are getting stranded over here. Vegetable lorries, okay, the lorries that carry food materials, they're also getting stranded. So they were not able to find out some solution for that. So what they did is like they started utilizing an innovative product called as GeoCell along this area. Okay, so what they did is like you have to effectively spread out this one, just fill any granular soil, okay, into these pockets, and effectively the load can be transferred, and effectively this geocells can perform. Okay, after erecting, after placing the geocells, this is the status of this particular road NH44, and you see that you can see the very beautiful view of this particular road once like this getting transformed to this, okay, in this position. Apart from that, let's say for example, if you want to construct a road momentarily in the desert regions of Rajasthan or any particular area, just to take this geocell, spread it out, fill up with the inherent material that is already available there on the site, and you can see that you can move a tanker on this particular geocell. So this is the way, or this is the advanced mechanism that's presently available to mobilize trucks, men, material, arms, okay, to anywhere, okay, in regions anywhere in and around the places. So these are all the applications, geocell applications. Okay, so I have just given the other applications. You can just go through. For the want of time, I'm not going through all of these things. Okay. The other important thing that I wanted to focus on is on a geocomposite called as your geosynthetic clay liner. Okay, GCL nu pere. So this geosynthetic clay liner is a composite geosynthetic material consisting of a layer of your sodium bentonite or a clay sandwiched between two geotextile layers. So you have a clay layer over here, clay powder sandwiched between two textiles, two geotextiles. One is called as your carrier, another one is called as a cover geotextile. So you have a unique application of this geosynthetic clay liner. We'll discuss it shortly. So you can see the better picture over here. So the hydraulic conductivity, you see that 10 power minus 11 to 10 power minus 13 meter per second. So think about the number of zeros that you want to add for the water to travel. So 10 power minus 11 learned 10 power minus 13 meter per second is the hydraulic conductivity or the permeability. So once தண்ணி உள்ள போச்சுனா it is almost impermeable. தண்ணி வெளியவே வராது. Why? Because this is a swelling clay. Okay, so this bentonite mass per unit area is around 3.5 to 7 kg per meter square. Thickness is 5 to 8 millimeters. Okay, so the thickness is only 5 to 8 millimeters. Think about how much is 1 millimeter. I want you to have a feel of how much could be 5 to 8 millimeters. அதனுடைய thickness கொஞ்சம் imagine பண்ணி பாருங்க. So the tensile strength, it has some tensile strength greater than or equal to 7 kN per meter. Peel strength is around 0.8 kN per meter. Internal shear strength is greater than around 15 kPa. Okay, so you have for all of these things, you have American Standard of Testing Materials Code, and you see that what happens is like if you are allowing water to pass through, it will pass through only in one side. Okay, what happens is like once it reaches the clay powder, the clay starts absorbing, the clay starts swelling, but it will not yield water. Okay, it will not yield water outside. Why? Because the permeability values for these clay or bentonite clay, sodium bentonite clay, is around 10 power minus 11 to 10 power minus 13 meter per second. I don't know how many of you have a physical feel of these numbers, but I want you to appreciate. So this is a better picture. You can see the clay powder here, and you can see the geotextiles. You can see the upper geotextile. You can see the lower geotextile. You can see the reinforcing fibers. Okay, connecting both the geotextiles. Okay, so this is going to be your landfills nu பேரு. தமிழ்நாட்டில் இன்ஃபேக்ட் சென்னையில் கூட ஒரு லேண்ட்ஃபில் இருக்கு. இட் இஸ் தேர் இன் கும்முடிப்பூண்டி. Whatever waste that is being generated in Chennai, I think some part of waste is being dumped inside the landfills. So one such landfill is available in Chennai. So how these landfills are constructed? In fact, geotechnical people are designing these landfills. You can see a drainage layer over here. You can see the geosynthetics provided over here. You can see the compacted soils. So towards the left and towards the right, you have compacted clay liners. 2-3 decades back, ஒரு 30-40 வருஷத்துக்கு முன்னாடிலாம் வெறும் சாயிலை மட்டும் யூஸ் பண்ணிட்டு இருந்தாங்க லைனரா. ஓகே, so now people have started using this geosynthetic clay liners. So இதில் என்ன ப்ராப்ளம் வரும்னா, so you see here you have the waste materials dumped over here. So these waste materials, when they are interacting with water, especially during monsoon seasons, especially during rainy seasons, or because of water table increase or whatsoever, when it is in contact with water, these waste generate a toxic kind of liquid called as leachate. So leachate is a very toxic, poisonous liquid that is generated out of this waste. And the very important criteria for a geotechnical engineer is that you should not permit that particular waste material to mix with the groundwater. ஸோ நிலத்தடி நீரில் அது கலக்காமல் பார்த்துக்கணும். தட்ஸ் த மேஜர் டாஸ்க். ஸோ அப்படி கலக்காமல் பார்த்துக்கிறதுக்கு உண்டான ஒரு எஃபெக்டிவான சொல்யூஷன் தான் your geosynthetic clay liner. Let's say, for example, these textiles are permeable. Okay, the toxic liquids may permeate into this geotextiles, but when it reaches this clay powder, the clay powder is going to absorb all the moisture, it's going to swell, but it does not permit those toxic liquids to penetrate or to reach the groundwater. Okay, இது ஒரு ஆஸ்பெக்ட்ல. இன்னொரு ஆஸ்பெக்ட் ஆஃப் த சேம் சைட், ஒரு காயின்ல ரெண்டு பக்கம்ன்ற மாதிரி இங்கே பாருங்க. லெட்ஸ் சே ஃபார் எக்ஸாம்பிள் யூ ஹேவ் காம்பாக்டட் சாயில் ஓவர் ஹியர். காம்பாக்டட் சாயில் இருக்கு இங்கே. ஸோ இந்த காம்பாக்டட் சாயில் வந்து இட் ஹேஸ் டு பி காம்பாக்டட் ஃபார் கிலோமீட்டர்ஸ் ஆர் ஃபார் ஹெக்டேர்ஸ் ஆர் ஃபார் மீட்டர்ஸ். ஸோ இவ்வளோ சாயில், நல்ல குவான்டிட்டி ஆஃப் சாயில் நமக்கு கிடைக்கிற சாயிலை எடுத்து வந்து டிரான்ஸ்போர்ட் பண்ணி இங்கே வச்சு காம்பாக்ட் பண்ணி இந்த ஸ்ட்ரக்சரை கிரியேட் பண்ணி. திஸ் இஸ் மியர்லி a cross section தான். அது ஆக்சுவல் ஸ்ட்ரக்சர் will be very very big. I'm going to show you a picture. So this structure, so this particular soil has to run for sometimes meters, sometimes kilometers. So அவ்வளோ சாயில் எடுத்துட்டு வந்து இந்த திக்னஸுக்கு காம்பேக்ட் பண்ணி கன்ஸ்ட்ரக்ட் பண்ணுறதை விட, what people thought is like for in place of this compacted soil, people started using this geosynthetic clay liners, which are more effective, in fact better than this compacted clay liners. In fact, there was a beautiful example that I used to show. I don't know whether I think I have it here or not. It's a much better picture that I'm showing here. So in the thickness வந்து பார்த்தீங்கன்னா around 1 meter, let's say for example 1 meter soil வந்து நம்ம எடுத்துட்டு வந்து இந்த லேயர்ல காம்பாக்ட் பண்ணி இந்த லேண்ட்ஃபில்ல நம்ம கன்ஸ்ட்ரக்ட் பண்றதுக்கு பதிலாக சின்ன திக்னஸ், லெட்ஸ் சே ஃபார் எக்ஸாம்பிள் 15 millimeter திக்னஸ்க்கு ஒரு ஜியோ மெம்பரேனை ஸ்ப்ரெட் பண்ணிட்டு we can construct this one. By doing this, I can save the cost, I can save the time. Okay, so again let's see one good example of how much is the tax, how much is the income savings. A beautiful example from some textbook. So US UK எல்லாம் பார்த்தீங்கன்னா அந்த இடத்த வந்து லீஸில் விட்டுருவாங்க லேண்ட்ஃபில் கன்ஸ்ட்ரக்ட் பண்ணுறதுக்கு. ஓவர் அ பீரியட் ஆஃப் டைம் மற்றவங்கெல்லாம் வேஸ்ட்டை ஜென்ரேட் பண்ணி உள்ளே டம்ப் பண்ணுறதுக்கு they have to pay the owner. Okay, so a landfill owner is considering replacing a 1 meter thick of a compacted clay with a 15 millimeter thick GCL. GCL is your geosynthetic clay liner as a part of the design of a new landfill liner. So the landfill has an area of 7.5 hectares. So and the fee collected per cubic meter of waste is $90. So 1 cubic meter waste, if I want to dump in the owner's landfill, okay, he is collecting around $90. So $1, I don't know currently what is the rate. The time which I have calculated is around 85 Indian rupees. How much additional income does the owner stand to collect from saving in the thickness of the liner? Okay, so he's trying to replace the 1 meter thick compacted clay with only 15 millimeter thick GCL. Okay, how much is the change in thickness, the change in height after replacing the compacted clay liner? So initially it is 1 meter, this is nothing but 1000 millimeter. If I subtract this 15 millimeters, I get only 0.985 meters. Okay, 0.985 meters is the effective height or effective thickness. So if you again calculate, so 1 hectare is around 10,000 square meters if I'm not wrong, and the fee collected is around $90 for 1 cubic meter. So the additional income, if you calculate for 1 hectare, let's say for example 90, that is nothing but $90. So 10,000, that is provided for conversion between your hectare to meters, and this thickness is 0.985 meters. So you get $8,86,500 for 1 hectare. So 1 hectare is going to get $8,86,500. So for 7.5 hectares, he is going to get this much amount. So you see here around Indian rupees, $90 is approximately equal to 7650 Indian rupees. So this much is the amount of additional income that he is going to get by replacing 1 meter thick of a compacted clay with 15 millimeter thick of a geosynthetic clay liner. Okay, ஒரு மீட்டர் திக் சாயிலை போட்டு ரீப்ளேஸ் பண்ணுறதுக்கு பதிலாக ஒரு 15 millimeter ஜஸ்ட் ஒரு ஜியோசிந்தட்டிக் கிளே லைனரை ஸ்ப்ரெட் அவுட் பண்ணுறது மூலியமா he is able to save this much amount. Okay, so this is the actual structure I want you to take a look. Okay, this will be the waste that is being dumped. You can have the protective soil cover. You have this geotextile cushion layer, and then you can see the geomembrane liner, which could be high density polyethylene or LLDP, which is nothing but your linear low density polyethylene. PVC is polyvinyl chloride. So we have different types of membranes made out of these multiple types of polymers. We have this geotextile protection layer also provided. So இந்த மெம்பரைன்லாம் டேமேஜ் ஆகாமல் இருக்கிறதுக்காக ஒரு குஷன் லேயராக geotextiles can be used. Compacted clay liners are already additionally provided. Why? Because the landfill owner maybe wanted to have a super safe landfill. Leak detection layers, you get to see one geonets. You have inspection chambers. Okay, you have this drainage layers as gravel over here, and finally when it reaches accidentally this particular place, you can just pull out these leachates before if it is trying to reach the ground level or a groundwater level. Especially during earthquakes, seismic activities, you don't have a control over all these things, but with geosynthetics the performance is much better. நீங்கள் வெறும் சாயிலை போட்டுட்டு காம்பேக்ட் பண்ணிவிட்டு இந்த சிஸ்டமை க்ரியேட் பண்ணும்போது கிடைக்கிற சேஃப்டியை விட ஜியோசிந்தட்டிக்ஸ் அப்ளை பண்ணதுக்கப்புறம் வாட் எவர் சேஃப்டி தட் வி ஆர் கெட்டிங் ஆஸ் இன்ஜினியர்ஸ் இஸ் மச் பெட்டர், மச் பெட்டர், எஸ்பெஷலி டூரிங் seismic activities. So why to use a geomembrane liner? Prevent migration of leachate to soil and groundwater. These are fundamentally high impermeable and chemically resistant. They are durable, they are UV resistant, cost effective, and then they are easy to install. Okay, and finally, if you see, they are environmentally sustainable solution. So the amount of expenses that are used in transportation, for oil, for excavation, all of these things can be avoided. So if they are avoided, you are saving time. If you are saving time, then you are saving money. If you are saving money, then you are a good engineer. Okay, so these are all some of the installation steps. I think I can share these slides with Dr. Hari. You can just go through that. So adu mattum kediyadu, there are a lot of other applications in offshore areas also, especially if you go to Chennai port or Tuticorin port, you have a lot of pipelines that are running in parallel, especially for creating jetties, especially for creating the shorelines. Okay, you need all these geotextiles as cushions, okay, for connecting members, for geomembranes. Multiple uses and multiple applications are available, especially for seabed preparation, coastal and shoreline protection, offshore containment systems, especially in oil storage tanks and industries. Okay, so I leave it to you. And right now you see here you have geotubes also. Geotubes are special structures wherein they are again type of fabrics or fabrics. 1 minute. Okay, so these geotextile tubes or geotubes are usually manufactured in specialized conditions from different companies. What they do is like they bring these geotextile tubes and they fill up with the dredging material. Okay, the dredging material vache they fill பண்ணிடுவாங்க. Once it gets filled, they'll just lay it over here. They can be used as shoreline protectors. Sometimes if you want the workers to move along this path, you can use this geotextile tubes also for laying the paths. Okay, so geosynthetics are used in dewatering. They can be used as geotubes, core containment for reclamation and dredged material management. So you have this geotextile tubes for silk curtains, reclamation area containments. Multiple uses are there. Okay, and especially for protecting all these pipes, you can use this geotextiles or composites. Okay, so this particular course is being taught to master's students in geotechnical engineering and as well as for PhD students. This is actually a 6-month course. There are different other mechanisms and concepts behind this geosynthetics or soil reinforcement. I'm just giving you a overall picture or an overall idea. Okay, so this is again one beautiful picture that shows the rock and concrete protection layer that is provided especially during dredging operations. And you can see how the geotextiles or geocomposites are provided just below the soils. You have these pipelines running in parallel. that can carry liquids as well as internet cables, whatever it is. And these pipelines are provided sufficient cushioning with the geotextiles and then placed exactly on the seabeds. So this particular section I am purposefully avoiding, but I am providing it to your teacher, Dr. Hari. Why? Because equivalently speaking, we have again natural materials. Natural materials are also available. Let's say, for example, in West Bengal, in Sri Lanka, in Kerala, you have equivalent products called coir, jute, sisal, hemp, bamboo, coconut fiber mattings. All of these things are used as reinforcements. Especially for geonaturals, there are only two products. One is called jute, the other one is called as coir. So in fact, people from Kerala, they are extensively making out all the products, geotextiles, geonets, made out of coir, made out of jute, coir blankets, and then they are using it effectively in different applications, especially for erosion control. And then the இடத்துலலாம் வந்து இப்போ மண் அரிப்பையோ இதெல்லாம் தடுக்கணுமோ, so that you can use this erosion control mats. Especially right now, you see, right now we have the Kaveri water coming from our neighboring state. And if you want to avoid the water loss, if you want to avoid the destruction of these earthen channels, so what you do is like you have to lay out all these natural materials. So these are biodegradable materials which have very short life. The life la romba kammi, whereas polymeric materials, they have pretty longer life than these short-lived materials. So again, you can see all of these applications, especially riverbank shoreline protections using natural ways, gabions, retaining structures made out of these coir geotextile wrapping. Gabions are nothing but steel wire baskets filled with aggregates, especially to increase the weight, to increase the stability, and for different gravity loading applications. Okay. So equivalently, all of these natural products, they can be useful for landslide prevention, okay, on slope protection, improving slope stability. And additionally, what you can do is like they'll spray all the seeds along this, natural products, namely coir or jute. So what happens during the monsoons? These seeds start to germinate. Once they germinate, they lay out the roots. These roots penetrate into the soil and they act as natural reinforcements. Okay. In fact, there is one of the natural beautiful reinforcement called as vetiver. Tamillayum the vetiver தான். Okay. So just go and type in internet the effective usage of vetiver as reinforcement. You'll get to see a lot of benefits. Okay. So that itself is a topic of discussion. I'm not touching here. This is again the final application. So these geotechnical applications are of multiple levels. It's like you have ponds, reservoirs, especially when you want to contain toxic liquids, but you don't have any other option. If you want to separate water from that particular toxic liquid, you can use all these, geosynthetics, such that these toxic liquids, let's say, for example, in industries, in ponds, these toxic liquids, if it should not enter inside this groundwater, what you can do is effectively uses geosynthetics. Canals, irrigation channels, to avoid water loss, to avoid the destruction of this, side channel, side protection, especially for tunnels dug in hilly areas or normal conditions where you can expect a lot of water to get pumped inside. You can use geosynthetics effectively. Oil storage tanks, industrial waste containments, you can use this geosynthetics. And apart from that, dams and embankments, in order to effectively arrest seepage, if you want to increase the quantity of water that has to be saved also, people are using this geosynthetics. Okay. So as a summary, we can see what we have seen, what is called as a geosynthetics. What is the mechanism of reinforcement? I have tried to explain. And to some extent, I have touched some applications in pavements, embankments, and to some extent offshore applications. Okay. So if anybody is interested, they can write to me. I'm available in this WhatsApp number and then through email. You can write to me, you can text me if you're interested to know more about this, geosynthetics. With this, I would like to complete my presentation. If there are any doubts, if there are any questions, I'm willing to take a few. Hari?
Yes, sir. Yes, sir. Any audience having any clarification related to the topic which was discussed by the speaker today? Yeah. Sir, one of the students asking doubt, sir.
Yes, please.
Sir, actually, you said no, sir. Like jute material, you do that geosynthetic material, no, sir. How it's lifespan over there? It try to decompose or degrade it, no, sir.
I am not able to hear your voice properly. Can you come again once more?
Sir, I'm audible.
Yes, to some extent. What is your exact question?
So he would like to ask, you have mentioned at the end of the slide, utilization of the coir as a reinforcement. He's asking about the life cycle of the coir.
Okay. Let's say, for example, you have a village. Okay. ஒரு கிராமம் இருக்குது. அந்த கிராமத்தில் வந்து ஒரு சின்ன பண்ட் இருக்குது. அந்த பண்டோட டெம்பரரியாக அந்த பண்டை கன்ஸ்ட்ரக்ட் பண்ணியிருக்காங்க. அந்த டெம்பரரியான பண்டில் வாட்டர் சீப்பேஜ் இருக்குது. அதுக்கு நம்ம வந்து ரீஎன்ஃபோர்ஸ்மெண்ட் கொடுக்கணும் அப்படின்னா யூ டோன்ட் ஹேவ் டு கோ ஃபார் அ பாலிமரிக் ரீஎன்ஃபோர்ஸ்மெண்ட், யூ கோ ஃபார் அ காயர் டைப் ரீஎன்ஃபோர்ஸ்மெண்ட். டெம்பரரியாக நமக்கு அந்த ஸ்டெபிலிட்டி இருந்தால் போதும். ஸோ அட் தட் டைம் வாட் யூ டூ இஸ் லைக் யூ சூஸ் அ காயர் ஆர் அ ஜூட் டைப் ஆஃப் reinforcement, maybe for 10 years, 5 years. So it will sustain. After that, what happens? This biodegradation starts. Because of this biodegradation, slowly this coir or jute will disappear with soil. Okay, for temporary applications you can go for all of these type of reinforcements, and for permanent structures where load is expected to be very, very high, you can go for polymeric reinforcements. Okay.
Say, any other doubts or any other question you would like to ask the speaker? Can come forward. Yes, I hope everybody who have attended the session understood the theme of the topic today's discussion. So the students doesn't have any other doubts.
Okay, Hari, maybe you can switch off the recordings. We can have a discussion on
sure.
This one.
So let me give a vote of thanks regarding the session. After that, let me switch off the recordings.
Okay, thank you then, Hari.
Yeah, I would like to extend my sincere thanks to the speaker for accepting an invitation, for delivering the topic. Also, he have highlighted many applications regarding the GCF. So that's the most emerging topic. That is most that will suitable for all type of applications. So when you are come out to the field site, so you come to know the importance of this. So I extend my sincere thanks to the speaker for highlighting everything with the beautiful pictures. So through this, every students have understood the core principle behind it. So also I would like to thank the management for encouraging conducting this type of lectures for the student. And also I extend my sincere thanks to the principal, deans and HODs and all. So with this, I would like to conclude this session. Sir, anything you would like to discuss?
Nothing. I welcome you all to NIT Jamshedpur sometime, and